Thank you very much, Isabel. So in order to dive right into the economics of climate change, let's look at what some of the most leading economists in the field have said about it. So this is a quote from Nicholas Stern. Nicholas Stern is a lord. He's professor of economics at LSE. He's the president of the British Academy. He's been the World Bank chief of economics. And in 2005, he was appointed by the UK government to lead an economic review of climate change. And this is what he said about it in 2006. He said that climate change is the greatest and widest ranging market failure ever seen, and that the benefits of strong early action on climate change outweigh the costs. So, and this Stern review actually received a huge amount of public attention as a call for sort of strong action on climate change. At the same time, we can look at what one of the other leading economists in the field said about the same issue. And this is William Nordhaus, who's a professor of economics at Yale. And he's currently the president of the American Economic Association. He's been a member of the President's Council of Economic Advisor, and he's seen as the economist who sort of started the field of economics, of the economics of climate change. And what he said in a study from 2003 was that modest restrictions on emissions today would yield net benefits in the future, but extensive restrictions would crowd out other types of investment. And given the contribution of fossil fuel use to both economic growth and climate change, the study found little benefit in slowing warming. So in other words, this is a quite different conclusion from that of Stern. And it is important to note that these studies were only done 3 years apart, and the difference that does not come from any sort of a change in the scientific understanding of climate change. Basically, both Stern and Nordhaus use the same basic assumptions about the structure of economic systems and also about how most of the parameters that might affect the results of the analysis. So the question then is, how did they reach such different conclusions? And basically, what I will do today is talk about the models that form the basis of their analysis. And these models are called integrated assessment models. They're called integrated because they include both the climate system and the economic system. And these models are seen as pioneering in the field of climate change economics. Importantly, these models, or the results from these models, are also used in current US lawmaking. So what I will do today is first talk a little bit about the economic theory behind integrated assessment models. They basically come from environmental economics, so we'll look at that. And then we'll see how this theory can be used and applied to the problem of climate change, which is the foundation for integrated assessment models. Then we'll look at the problems of integrated assessment models, and then at the end, just a few examples of how it's being used for policy. Okay, so going back to the beginning, we basically have the economics of welfare in 1920, which was written by Arthur Pigou. Arthur Pigou was a Cambridge economist who basically defined the concept of externalities. And this text is seen as leading in, or an essential text in environmental economics. And an externality is basically an impact, which can be either positive or negative, to a third party as a result of an economic transaction. So, in other words, a buyer and a seller are interacting through the market, but then someone who's not the buyer or the seller is affected in either a positive or a negative way. And when externalities are present, we basically have market failures. This means that the market equilibrium is not efficient, or in other words, it's not socially optimal. And in this way, environmental economics can be seen as a branch of welfare economics, and the goal of environmental economics is therefore the same as in welfare economics, which is to maximize welfare. And just to have two examples of externalities. Here we have on the production side, we might have a factory that is polluting, say, a river at no charge. Then this river might be important for a downstream farmer who's using the river as a water source. Then this creates an externality for the farmer. On the consumption side, the use of cars will lead to externalities for people who live in cities or nearby roads in terms of increased air pollution and increased noise. Externalities can also be illustrated using the standard supply and demand curves from economics. Here we have the demand, which is basically the marginal benefit, is the blue line here, and the standard supply curve is the black line here, which is equal to the marginal private costs. And we have the demand and the supply meeting to form the market quantity or the market equilibrium. When we have an externality present, a negative externality, for instance, think about the factory. We have negative externalities for all the farmers living downstream. We might have some negative externalities for people that are using this river for recreational purposes. And then if we add the loss that these third parties experience, so the cost for them, if we add that to the marginal private cost, we get the marginal social cost, which is basically the marginal private cost plus the externality. And the condition for social optimality is that the marginal benefit equals the total marginal cost or the marginal social cost, which we see over here. And we can see that the social optimal point is to the left of the market equilibrium. So in other words, when we have a negative externality, the result is that the market produces more than what's social optimal of the good in question. The solution to a negative externality will typically be to impose what's called a Peruvian tax. Now, the Peruvian tax is basically set equal to the additional cost of the pollution. When you do this, you essentially move the market supply curve to the curve that you want to have in order to reflect your social optimum. And in this way, you basically get the sort of optimal level of pollution. And it's important to note that from the perspective of environmental economics, if you ask what's the optimal pollution, the answer to that will not be zero pollution. It will be a certain amount of pollution. More specifically, it will be the point where marginal cost equals marginal benefits. So let's now take this theory, the theory of externalities from environmental economics, and apply it to climate change. Basically, viewed from the perspective of environmental economics, the problem of climate change is that on both the production and consumption side, we have emissions of greenhouse gases, CO2 and other gases. These gases are absorbed by the atmosphere, which leads to global warming, which leads to climate change, which then has negative impacts to nature and to human livelihoods. Let's see. Yeah, so then essentially, based on the theory, the solution becomes basically to find the optimal level of greenhouse gases. And this is the point, again, where the marginal costs of climate change mitigation, or the marginal cost of controlling emissions, will equal the marginal benefits of controlling emissions. And note here that the marginal benefits of controlling emissions are essentially the avoided damages, okay? So the marginal benefits of control is the same as the costs of climate change. And in order to apply the theory of externalities, what we essentially want to do is find the level of optimal pollution, which then requires us first to define the social cost of carbon, okay? And in order to find this social cost of carbon, we want to use the integrated assessment models. So that's essentially what the integrated assessment models do, is calculate this optimal point, which reflects the social cost of carbon. Okay, so now I'm going to try and explain what integrated assessment models do. They are, on the one hand, fairly complicated models. On the other hand, they're actually quite simple when you think about what they're actually trying to do. Basically, integrated assessment models are trying to find the total cost and benefit of climate change globally for 100 or 200 years ahead. So that's quite a big task. Basically, the basic structure consists of two different modules. So we have the climate module, which is fairly simplified in order to fit into the economic framework. And then we have the economic module, which is also fairly simplified. And essentially, we have 7 different sort of compartments here with 7 different links or relationships, which are essentially represented by mathematical equations connecting each of these compartments. Basically, the computation involved here goes through a number of steps, but it starts in the upper left-hand corner. And essentially, the first step is to first predict the likely greenhouse gas emissions over the next 50, 100, 200 years, right? And we start with a business as usual scenario, which is basically our baseline. This is the baseline that we use to compare all the other mitigation scenarios against. So here we have 2 scenarios. One is the business as usual, which is the same. And the other one is the mitigation scenario, which we can vary. So we can vary using different levels of carbon taxes, for instance. And from the predictions of emissions in these 2 scenarios, we basically get the concentrations of greenhouse gases in the atmosphere. That step is fairly simple, actually. Now, the next step is going from concentrations to temperature increases. This step is a little bit more complicated because climate science tells us that we do not actually know exactly what concentrations will lead to what temperature increases. We have some kind of probabilistic understanding, but it's nowhere near deterministic. And then the third step, or the third link, is a very important link in these models. And that's the one where we go from temperature change to GDP losses. Now that's a huge step. Basically, we want to be able to say how much we lose in terms of GDP for each degree of warming. And in order to do this, integrated assessment models use what's called damage functions. Now, the next step after having the GDP losses is basically to take the GDP in the business as usual scenario and then compare that with the mitigation scenario. And then you'll see basically that the GDP loss will be smaller the more you sort of reduce climate change. And the next step is therefore to compare these two. In comparing these GDP losses, however, there's another very crucial step, which is that, or it comes from the fact that basically for climate change, most of the costs of mitigation accrue today, whereas most of the benefits accrue in the future. And in order to compare everything in today's values, we need to discount the future benefits. Okay, so we need to calculate the net present value of these sort of GDP streams. And in order to do that, we need to know how much we should discount the future benefits and costs. And this discount rate comes in here as rho. Now, if we go back to the left-hand side, we have the abatement costs. And these are calculated based on the two different scenarios that we started with. Essentially, reducing greenhouse gas emissions costs money. We need to move investments from fossil fuels to renewable energy. We need to change infrastructure. We need to change transportation, and so on. And then finally, sort of the ultimate goal or endpoint of these models is to compare the costs of mitigation with the benefits of mitigation. And what they do then to find the optimal level of greenhouse gas emissions is essentially maximize the net benefit, which is the benefit minus the cost. Okay, are there any questions about this now, by the way? Because it's sort of complicated. No. Yeah?
Did you call them the damage functions?
The damage function? Yeah, that's the damage functions. Yeah, so basically that's how you get from here to here. But I will actually come back to that, because the next thing I'm going to do is point to the various problems of this. And then I'll talk about the damage function again. So basically, integrated assessment models have been heavily criticized, both from outside of economics, typically from environmental philosophers and ethicists, but also from other economists, including neoclassical economists. And I will only have time to go through a few of the problems. There are more problems than the ones I've listed here, and I could probably spend a whole lecture on each one of them. So this will be a very brief overview, but nonetheless. So let's start with the first problem here, which is essentially relates to the fact that in order to do these comparisons, it's essentially a massive global cost-benefit analysis over time, right? And in order to do that, you basically need to monetize all the impacts. And that really means every single impact. And that includes the value of ecosystem services, species, human lives, things like national parks, coral reefs, everything that's affected by climate change. Now, this is problematic both from an empirical perspective and from an ethical perspective. So economists will generally agree that the measurements of monetary values of sort of non-market objects like these, they're fraught with challenges. First of all, the results typically depend on what kind of methods you use to do the measurements. For instance, if you want to find the value of a park, you might use willingness to pay studies, where you ask people how much they would be willing to pay to protect this park. Or you could use willingness to accept studies, where you can ask how much compensation people would require if the park was to be destroyed. And depending on which one of those two you use, you will usually get different results. A third method of measuring these monetary impacts is to use hedonic pricing, where you basically use market values as proxies for these types of values. And in the case of a national park, you might look at the difference in real estate prices closer to the park and further away from the park to see if sort of this park adds any value to housing. But again, the results that you get from the analysis will depend on the method you use. More essentially, It's a problem in that basically consumers don't have any experience of climate change yet. So it will mostly be guesses. Like you don't really necessarily know how you value these kinds of things because you've never experienced it before. But nonetheless, economists will argue that in principle at least, you can measure everything on the same scale in order to compare. Now, the criticism from environmental philosophers and ethicists will point to more sort of fundamental problems with these kinds of measurements. One problem is that poor people sell cheap, essentially, in willingness to pay studies. Rich people have more ability to pay, and they will therefore usually be willing to pay more, which means that rich people's preferences are given more weight in these kinds of studies. On a more fundamental level, environmental philosophers will usually point to the fact that things like increased consumption of consumer goods is simply not commensurable with, for instance, health impacts or value of human lives. So you both cannot and you should not compare those kinds of things on the same scale. Now, the second problem with integrated assessment models comes down to the discount rate. So basically, like I said, in order to aggregate the impacts over time, you need to decide what discount rate you're using. Now, this has been highly contentious. It's been debated since Nordhaus basically created the first model in 1992, and it's still debated more than 20 years later, and there's basically no agreement whatsoever on the value of the discount rate. Essentially, the higher the discount rate you use, the less the welfare of future generations counts, okay? And because the interest rate also compounds over time, the effect when you look 50 or 100 years into the future is enormous if you choose only slight differences in the discount rate. If you have a high discount rate, things like losing Miami in 200 years won't really count for that much. And basically, this also answers the question of why Stern's and Nordhaus's conclusions were different. Basically, it boils down to the difference in the number for the discount rate. So Stern used a low discount rate of 1.4%, and Nordhaus used a high discount rate of 4.5%. Now, Stern and others that agree with him argue from a point of intergenerational justice, and they say that basically high discount rates are ethically questionable or indefensible because future generations should count just as much as current generations. Nordhaus, on the other hand, comes from a more sort of positivist American perspective, and according to him, the discount rate should reflect the market interest rates, because it should reflect, or he looks at the economics of climate change as an investment problem, and you either choose to invest in climate change mitigation, or you choose to invest in other things that will increase economic growth and therefore will increase economic well-being in the future. And in order to sort of adequately compare these investments, you need to use the market rate. Okay, so the next point I want to make is just simply that even though economic models have become increasingly sophisticated for these integrated assessment models in general, forecasting the future is still inherently uncertain. In order to even begin to sort of compare the mitigation scenarios, you first need to know what the business as usual scenario is. And that actually in and of itself is extremely difficult. It requires that you can predict economic growth, carbon intensity, technological development, and so on for decades into the future. Fourth point I want to make comes back to the damage function. And essentially, because climate change is new and we have no experience of it, these damage functions are best guesses. And according to critics, these functions have no empirical basis and are completely made up. One of the problems is that these integrated assessment models are mathematical models, and as mathematical models, there are certain requirements in order to be able to actually do the calculations. And basically, you want to have damage functions that are relatively smooth. So that means that you'll usually have some kind of form based on what you think is the best guess, where you have increasing damages for increasing temperatures. But what these kinds of functions typically won't reflect is catastrophic and sudden, irreversible climate change effects. And now, it's important to remember that it's precisely the probability of these catastrophic events that's one of the main reasons why we want to actually mitigate climate change. The last point I want to make is the point about the climate sensitivity. The climate sensitivity, if you remember, was the link that goes from the greenhouse gas concentrations to the temperature increases. Now that's a purely sort of scientific relationship, but the important point here is that first of all, because of scientific uncertainty, we don't know this relationship in any deterministic way, but still the integrated assessment models again have to make some kind of best guess based on the science, and they do end up giving you sort of a single number. If you've seen any of the graphs for climate change where you have the temperature increase, you will usually see an uncertainty band around the line. But in integrated assessment models, instead of reflecting this uncertainty, which is inherent to climate change itself, you basically end up getting single numbers. So, in other words, there are lots of problems with these models, and I could mention more if I had time. But one of the points to make is that these points have not only been pointed out by sort of environmental philosophers or ethicists or other people outside of economics, they've also been pointed out by well-renowned economists, like, for instance, Pindyck, who's been quite vocal about the problems with these models. Pindyck is a professor of economics and finance at MIT, and he wrote an article in 2013 where he said that these models have crucial flaws that make them close to useless as tools for policy analysis. Integrated assessment-based analysis of climate policy create a perception of knowledge and precision, but that perception is illusory and misleading. So, in other words, this is a quite damning critique of these models from a well-respected economist. So what's interesting to see in light of all these problems and in light of the critique that it has received is that they're still being used in policy. And in 2010, the US federal government essentially established what's called the Interagency Working Group, which was made to, or asked to review and determine a set of estimates for the social cost of carbon to be used in federal rulemaking. So here you essentially have all the different estimates for the social cost of carbon, and then you have different estimates depending on what discount rate that you use. And on the left-hand side here, you have the different integrated assessment models. Essentially, the interagency working group used 3 different integrated assessment models. It should be said that they all have the same sort of structure. They make the same assumptions. Everything I just said holds for all of them. They have slight differences that are more in the detail, really. Some of them have more sectors, others have fewer sectors, and so on. Essentially, DICE, which is mentioned several times here, is the model that was developed and used by Nordhaus. And PAGE is the model that was used by Stern. PAGE is developed here at Cambridge by someone called Chris Hope, who's the same name as the other coordinator of Paper Zero, which is funny, but he's a different person. And then FUND, I think, was developed in Holland. And one thing that's interesting to see here is that, first of all, you get a range of estimates. And instead of choosing one specific discount rate, the working group decided to use 3 different ones, 2.5, 3, and 5%, because there's been so much debate around this value. But still, the number used by Stern actually falls completely outside of the range. Okay, so that shows some of the differences between the sort of UK analysis and the US analysis of climate change. Now, as of January 2014, there were 58 proposed or final rules that used the social cost of carbon in US rulemaking. And essentially the way it's used is in cost-benefit analysis of various policies that somehow have an effect on carbon emissions. And then the social cost of carbon is added to the benefit side of these policies. So lastly, what I want to point out is that although few modelers would claim that their results represent precise projections of the future, and whereas most are quick to point out the assumptions and uncertainties inherent in their analysis, these kinds of caveats are usually lost when the findings are portrayed to the general public and to policymakers. Essentially, bottom line numbers are widely cited in the policy debate as if they were sort of precise and scientific numbers. Quantitative analysis is generally seen as a proof of expertise, and because of all the different things that go into integrated assessment models, they can basically work as black boxes for policymakers. And basically, some concluding remarks. I think it's fair to ask whether integrated assessment models are useful at all if we cannot adequately measure, predict, and aggregate the costs and benefits of climate change mitigation. And we've seen that ultimately some of the modeling decisions, like for instance the discount rate or measurements of the value of human lives, run into ethics. I think we can ask whether the theory of externalities has been basically extended too far. When it comes to climate change, we're not talking about a local factory where pollution is limited sort of in time and space. We're talking about a global problem that has consequences far into the future. And lastly, it's worth asking whether the concept of environmental externalities actually captures the pervasiveness of greenhouse gas emissions. In 1950, CAP criticized the concept of externalities as failing to recognize how economic systems operate. Given that firms are meant to maximize profits and that individuals seek their own best interest. The pushing of damages, he argued, onto others and avoiding the associated cost is to be expected as a normal and prevalent activity of the successful economic agent. And according to CUP, pollution is internal to the economy and to economic activity. And I think that especially when it comes to greenhouse gas emissions and the way that fossil fuels are involved in the economy, it makes sense to look at this as something more internal to the economy rather than something additional or sort of as an externality to it. And that's it. And here are some further readings. Both Nordhaus's own arguments and then Pindick's reply. And at the end, a very short and accessible book by Ackerman that really nicely summarizes the debate. Thank you. Another criticism, which I didn't mention here, is one by Weitzman, who's a pretty well-renowned economist too, and he's argued that instead of looking at this in a sort of cost-benefit way, we should look at climate change mitigation as insurance, essentially. So that's a completely different way of using economic theory to analyze climate change. Any other questions? Yeah?
What is your opinion on viewing climate change action as insurance?
As insurance?
Over cost-benefit analysis.
I haven't looked into it in detail. I think sort of intuitively it makes a lot more sense. Yeah, because I think that reflects more the reasons why we want to avoid climate change. Is sort of there's this small but significant risk of really catastrophic climate change. It's maybe on the order of 2% or something like that, but we essentially buy insurance to protect our houses from fire based on lower probabilities than that.
And without engaging in complicated cost analysis of how likely it is we're going to get that kind of...
Yeah, and I think that basically the number you get, the sort of optimal single number that you get, makes very little sense considering all the uncertainties and all the complications within the models. I think there are problems with the insurance approach too, because again, the usual methods that we use to calculate insurance are also based on sort of past experiences and knowledge of values and costs, and we don't really have that for climate change. Yeah.
I was curious to know your take on cap and trade and these kind of other public goods, like air being a public good, being commodified in a way. So I don't quite remember what Ackerman said when we had to read him for a discussion class in economics. I believe he spoke positively, but I might be wrong. But I just wanted to know what your opinion was, because just to me, I feel like it can go down a slippery slope of like richer companies and corporations just buying their way to continue polluting.
Yeah, so you're right. I mean, the cap and trade has been criticized because it's seen as sort of morally wrong in some ways, because you essentially, if you have enough money, you can just pay to pollute. And now there is, and I didn't mention this at all, but there is a lot of economic analysis also going into which policy instrument we should choose to mitigate climate change. And based on the theory of environmental economics, you basically, the conclusion is sort of that from an efficiency argument, you should either use taxes or you should use cap and trade. And they essentially do the same thing. Taxes guarantee a certain price. Cap and trade guarantee a certain quantity of emissions. So they're different in that way. But if you sort of calculate them according to the theory, you end up with the same sort of social optimum, which is the reason for choosing them. So they're based basically on an argument of efficiency as opposed to regulation, which is historically what's been used more and which has been very efficient in terms of actually reducing the emission. The argument is that regulation is less efficient in economic terms because you can't necessarily reduce emissions where it's cheapest. Now, I think that it's hard to answer. I think probably a mixture of these different instruments would be the best thing. I think that there are some good arguments for cap and trade, but from experience, for instance, from the EU market, it hasn't really worked out because the price of carbon emissions has just been too low. So it hasn't really had an effect on actually reducing emissions. And you find that basically companies might argue for this kind of, for the cap and trade sort of solution, sort of to avoid reducing emissions.
Right, so I don't know, I think it's hard to kind of say what's a reasonable price to put cap and trade, but like right now it is too low, so it's not really doing much. But then I guess you get into all sorts of problems if you try and make it exorbitantly high, so that it's almost punishing corporations, right? So like, which I guess part of me feels very like that's catharsis for me, just like, okay, punish them. But like but I guess then they can argue, and with foundation, this will affect the economy. Especially in a lot of developing countries where they feel like it's a restriction. Like help us develop first and then we can kind of...
Yeah. I mean, I think it is important from a sort of feasibility perspective that you actually, first of all, you need to have some kind of predictability for industry. And you need to sort of, I think, slowly increase the taxes or the price in a predictable manner so that they can actually adjust and actually have time to change practices to sort of less carbon intensive practices, essentially.
Do you really think we can, address climate change without addressing wealth and income inequality on a global scale?
I think it's basically an ethical issue in many ways, right? Climate change. So no. I mean, I think separating the two is problematic. Yeah. I think that's largely what economics tries to do. It tries to look at efficiency, and then it sort of ignores the distributional questions. Stern, at least, made an attempt to actually say that this is about ethics, and this is why we should set the discount rate low, because actually future generations are worth just as much. But again, it's also sort of a mistake to think of it as just current generations versus future generations, and basically. Nordhaus's argument boils down to him saying that actually, because of economic growth, future generations will be richer, which means that if we use too much money today to reduce climate change, we, the poor generation, will spend too much money compared to the rich future generations. But in reality, if you break it down, it's actually rich generations today that are affecting poor generations in the future.
And isn't he also assuming that there will be a future? Yeah. Money is not useful if you're dead as a population.
Yeah, I mean, both of them also assume that economic growth will continue,
but 200
even if we have severe sort of impacts from climate change, which is a questionable assumption.
Yeah, we're still on the calculations where there were different discount rates used to show this table. Why was Stern's so much? Why was the kind of lower bracket so far above Stern's in the different discount rates? And how was the fact that
there were multiple kind of numbers generated through different discount rates. How were those numbers used and why by different actors?
Yeah, so basically so this is the US, the interagency working group, and they used the range in order to avoid the debate. And the range that they used essentially reflected the US, the American integrated assessment models. And that range is essentially outside of the number that Stern used. And all of the American economists involved in these models were sort of heavily criticizing Stern for his approach, which they think is just completely wrong, because this has nothing to do with ethics. According to them, it's purely descriptive. So, yeah. Okay, thank you.
We'll have Matt Flight next week, speaking about the role of data and economic knowledge, so we hope you join us there.